Welcome to Spring LIB.
In this question, given data is that is there is a ballistic pendulum given. So consider that this is a figure of ballistic pendulum, and in the question it is saying that there is a bullet. So this consider that this is a bullet, and further data is that is mass of ballistic pendulum is given, that is capital M is equal to 5 kg, and the bullet mass is given, that is this is a bullet, and bullet mass is given, that is small m is equal to 25 gram. Now in the question it is saying that this bullet is going in this horizontal direction with speed given, that is v, and hitting the ballistic pendulum. Then after it the collision, what happened is this the center of this ballistic pendulum is raises by 10 centimeter. That means I can say that the new condition of ballistic pendulum will be assumed that this by raising its vertical displacement with respect to initial position, that is 10 centimeter. And one more thing is happening, that this bullet is embedded in it. That means the bullet is also stick with ballistic pendulum. So consider that this is a bullet. So after collision this thing is happened. Now in the question it is saying that by using this data we have to find the speed of bullet. Now I am answering this question, so let's start answering the given question. So in the answer I can say that consider final velocity of bullet is final velocity is that will be equal to v, and this velocity will be final. That means after collision you can see that this bullet is cling with the ballistic pendulum. So I can say that this final velocity will be for both complete system. That means in the system that will come, that is ballistic pendulum and the bullet. So here I will consider that final velocity for ballistic pendulum and bullet will be, that is v, that is common. That means, and direction will be same in which the bullet is coming to hit the ballistic pendulum. So now next step is, here I am applying the law of conservation of linear momentum. So I can say that according to law of conservation of linear momentum, the next step will be written as, that is initial momentum is equal to final momentum. That means on the left side I will write that is initial momentum, that will be written as, that is mu plus capital M multiplied by 0, because you can see that in the initial condition this bullet is going with speed v, and this ballistic pendulum is at initially rest condition. So I can say that here I had written the value of velocity for ballistic pendulum, that is 0, and now on the right side it will be written as, that is final momentum. Final momentum will be written as you see in this figure. After collision you can see that this bullet is clinging with ballistic pendulum and going with the velocity, that is which I assume that is final velocity v. So I can say that here I will write the final momentum, that is small m plus capital M, parenthesis of small m plus capital M multiplied by v. Now next step is substitute the data, so that I will get the v in term of u. So it will be written as, that is mu means m is given in the question, that is 25 gram, or I can say that in the kg it will be written as, that is 0.025 kg. So I can say that here I am writing that is m, that is equal to 0.025 multiplied by u, plus this will become 0, that will be equal to, now capital M small m plus parenthesis of small m plus capital M will be written as, that is 0.025 plus capital M, that will be mass of ballistic pendulum, so that means 5 kg. So after adding, final value is, that is 5.025 multiplied by V. Now simplify it, then I will get the V, that is equal to 0. U over 201. So now next step is apply the law of conservation of energy. So it will be written as, that is, so according to this law, that is law of conservation of energy, I can say that the left side will be, that is half multiplied by parenthesis of m plus capital M plus small m v square. That means the kinetic energy after collision will be written as in term of potential energy. So I can say that will be written as, that is on the right side, that is capital M plus small m parenthesis of capital M plus small m multiplied by g multiplied by h. H is a vertical displacement. So in the question it is given, that is the center of ballistic pendulum after collision raises by 10 centimeters. So I can say that here h will be written as, that is 10 centimeter, or I can say that in the meter it will be written as, that is 0.1 meter. So now substitute the data, so it will be written as, that is half capital M parenthesis of capital M plus small m, that will be, you can see that here after simplifying, so on the both side this term will be cancelled out by dividing by capital M plus small m to the both side. So I can say that the next in the result it will be written as, that is half multiplied by V square. So V square will be, that use this value of V from above step. So here I can say that V square will be, that is U over 201 square is equal to GH. G will be, that is 10 multiplied by H will be, that is 0.1. G is a gravity and we know the value, that is 10 meter per second square. So now next step is simplify it, then I will get the value of U, that is equal to 201 multiplied by square root of 2, or I can say that final value is, that is 280 meter per second. So this is the answer of given question. That means I can say that bullet strikes the pendulum with a speed, that is with a velocity of, that means U of 280 meter per second. So I had solved the question completely. Thank you.